And welcome to the Daily Space Weather. We are back with a lot of exciting stuff to cover. Once again, expecting the possibility of Aurora at mid-latitudes tonight as a result of a dual coronal mass ejection impact. We may already be seeing some of that showing up early once again, perhaps. We'll cover it and lots more at the Smash News Network, least busted name of news, bringing you your space and Earth weather together in absolutely unprecedented detail. So this is the last 24 hours in SDO 304 angstroms ionized helium. We're going to add 193 angstroms there to gain some additional contrast, especially over solar filaments. There are still a few in the Earth-facing portion of the solar disk. You may see one erupting up here in the northwest that did cause a coronal mass ejection, as well as some splashback, so some little uptick in X-ray output there. You'll be able to see it on this imagery. We've seen an overall downtick in solar activity, but we're about to see a big uptick, geomagnetically speaking, in earthly activity. Let's take a look at the equatorial region next. These are all 24-hour videos, by the way. And almost all of the sunspots are kind of right moving into the Earth-facing zone here. So the likelihood of solar flares actually goes down as a result of that, just the proximity, the location of those sunspots. And we've seen a decrease in the radio flux also. So another prime example of how solar activity can drop while geomagnetic activity on Earth can rise precipitously, which is what we're expecting tonight. In fact, later this afternoon is when we're expecting the CMEs to start arriving. We're expecting about 12 to 18 hours of coronal mass ejection activity there. You can see some secondary flaring happening here as plasma splashes back down toward the chromosphere. Great imagery there. And let's take a look at sunspots. So here is yesterday plus today for sunspots. A little bit of modest growth back here. Besides that, those groups mostly stable. No new groups have risen or formed, at least that I've noticed. Here's colorized magnetogram for yesterday plus today. Just give that a minute to initialize there. Come on, SDO website. I know you can handle it. Or is it the PC? Don't worry, folks. We've just upgraded. We got a new PC just last night. It's not being used for this video yet, but it will increase our capabilities. Well, are you gonna play or no? Fantastic. So there you go. Why it wasn't playing, I have no freaking idea. But there you have it. The SDO colorized magnetogram. So going to cover lots more things here, starting out with what's going on Croissant Earth. Yeah, Croissant Earth. Starting with volcanoes. So that thermal image there, that is actually Etna. Some minor eruptions there at Etna, generating a small amount of ash. And about a 5,000-foot plume of volcanic ash there over Etna. Katla on southern Iceland might be making people mad because it's been downgraded to green. Yeah, so it's now much less likely to erupt, probably making some people sad as they are hoping for an end to civilization so that their idiotic theories can be considered correct. Semeru also erupting. It's producing a 14,000-foot plume of volcanic ash over East Java, Indonesia. It's a flight level 140. Flight level 240 over Popocatépetl. A 10,000-foot taller plume of volcanic ash over central Mexico at 24,000 feet. 17,500 feet over Fuego in Guatemala. It's a flight level 175, flight level 150 over Revenador, and unable to detect Sabancaya. Please do not assume that it is not erupting, and decide to go on a volcanic vacation with your vault pole and pole vault the caldera. Don't do it. If you're going on a volcanic vacation, leave that vault pole at home. And check out the links below the video in your spare time. You'll find our Red Bubble shop, and our bestseller remains the Do Not Pole Vault the Caldera products. Now, I own the socks. I've also got a Do Not Pole Vault the Caldera shirt in green, which I don't wear too much on the videos because my keying keys me out. I am in front of a green screen right now afterwards. Anyway, our finest days lie ahead, folks, so just keep that in mind. Don't be fatalistic. This is a message of positivity. Our finest days lie ahead, so don't pole vault the caldera. Newsflash, civilization's not really ending. The galaxy's not going to kill you. The sun's not going to kill you. However, terrible decisions by humans, especially bureaucrats who are unable to get out of their own way, might kill you. So in the meantime, maximize your capabilities and do not pole vault the caldera. Let's see what's going on seismically. It's been pretty calm over the past 24 hours. Low seismic activity. Only a few quakes over a 5 magnitude. Most of the activity here in the western Pacific Rim, as you can see on the USGS map. We'll scroll up the list citing quakes over a 5. So one of the ones we saw over a 5 magnitude was this 5.2 at Kamchatka. That was at 15:58 yesterday afternoon. Later there was a 5.1 north of New Zealand, in between New Zealand and the Kermadec Islands. That was at 16:59 Universal Time. Chile had a 5.2 at 6:29 Universal Time this morning on May 7th. And that's it. Only 3 5 magnitude quakes in the past 24 hours. And it's time to get back to space. So here are the past 24 hours in SDO 171 angstroms, the house favorite wavelength. And if you're not familiar with the SDO imagery, the AIA instrument takes imagery of very specific bands of the extreme ultraviolet spectrum. And those 171 angstroms emissions are the emissions of ionized iron. Here we've added 131 angstroms to add a little bit of additional data there. That's going to show you active regions. And it'll show you plasma orienting to magnetic field lines. If you think that looks like magnetic field line, it's because those are magnetic field lines. And the 10.7 centimeter radio flux has actually dropped to 152 solar flux units, dropping below the support level around 155. So the sun just toying with support levels here repeatedly as we keep seeing this 155 solar flux units starting right there. That is the past year of radio flux, and it's this black line here. So that black line is the radio flux. The red line below it is the sunspot number. You can see this yourself if you like. If you want to monitor this, it's updated daily at solon.info/solar. Yeah, solon.info/solar. And next we'll move to the Space Weather Enthusiast dashboard here. I want to talk a bit about forecasting. Now, you can see NOAA's forecast for the arrival of the coronal mass ejection in earnest is almost identical to ours. We're expecting it to arrive sometime after 12 noon Universal Time today. Again, stay alert for Aurora. So we could see Aurora tonight and tomorrow morning also, and maybe even tomorrow night and Tuesday morning. So that's we're hoping to see some Aurora here at mid-latitudes. It's a double whammy coronal mass ejection impact, and there probably will be a coronal hole somehow mixed in there as well. So multiple different things. It's really a triple whammy. 2 different CMEs that are earthly directed, or at least have Earth-directed components, and a coronal hole high-speed stream from a well-defined trans-equatorial North Pole-oriented coronal hole, which we will show you here in a moment. So here is the situation. This is the NOAA forecast. And we had a little discussion in the live chat yesterday about these forecasts. Now, these are a little bit different. The NOAA and NASA forecasts are different. The shading here is showing you, this is velocity, up here is density, and it's showing you the impact times. Now, it does not show you magnetic field lines on the NOAA forecast data. That's the NOAA Enlil spiral. So it models the coronal mass ejections and coronal hole high-speed streams. So you can see this streamer right here. Those are coronal hole streams. And then you can see those cloud-like features. Those are coronal mass ejections. NASA's forecast is quite different in that it models the interplanetary magnetic field So here's NASA's forecast. And here you can see these dotted lines. These are the three-dimensional interplanetary magnetic field line. So when the plasma does head down that line, it does affect things like Earth's magnetotail. And see, what I'm showing you here is that this does indeed show coronal hole high-speed streams. It's just the one that showed up yesterday and caused a brief geomagnetic storm was not modeled by anybody's. So nobody was expecting that coronal hole high-speed stream to show up yesterday. Since then, it has subsided, but we are expecting a second one, as the one that showed up yesterday was from a very far south coronal hole, which we'll show you here momentarily. First, let's blast through some additional data to show you what's going on. So here is Earth's magnetic moment from space for the past 4 hours. We're back to geomagnetically calm conditions here. We just did see another minor uptick in the solar wind parameters, but it doesn't look like either of the CME impacts. If it is one of the CME impacts, it's definitely a dud. So we'll get to the real-time solar wind here first. That's Earth's magnetic moment from space for the past 4 hours. We'll show Earth's magnetic moment from the ground for the past 4 hours. And if you want to monitor the most likely places to see the aurora, this is one of the series of images you can use. Also, you can look at the geoelectric field, which we streamed yesterday for an extended period of time. We'll show you that here in a minute and how to find it. So this is Earth's magnetic moment from the ground in nanotesla. If you're worried about Earth's magnetic poles flipping, well, how come the telluric currents depicted in this image, in these images here, how come those aren't all out of place? It just doesn't add up with people's ridiculous theories about the end of times. By the way, the end of times is the oldest grift of all time. It probably dates back to when language was first invented. And let's take a look at the experimental data here. So this is one of the great things. This all the way down at the bottom of the Space Weather Prediction Center, you'll find all these links under products and data. You'll find this one, US Canada 1D geoelectric field 1 minute. This will show you the induction into the power grid. So if this will auto update. You can just keep this playing, and this will be something that we'll be showing regularly during times of geomagnetic storm conditions, as that induction into the power grid happens almost immediately. And the aurora can appear and disappear as fast as it came. So keep in mind these things happen very suddenly, and they subside just as quickly as they arrived. So you have to be prepared for it. It's one of the challenges of space weather forecasting, being able to capture the aurora. It's not as easy as you may think. And of course, the farther south you get, the harder it gets. That is depicting millivolts. Millivolts per kilometer induced electricity into the electrical grid. So the KP index is currently at 2. Again, it's geomagnetically calm at the moment. KP index is a general average of global geomagnetism. And here you see this little uptick in the solar wind. Speed went up to 474. Density went up to about 17 protons per cubic centimeter. And then quickly subsided. So it looks like that could be a CME impact. If so, it's very minor. There was also a shift in the magnetic field and phi angle at the time. However, not a big shift in the solar wind temperature. That's the lower pane there, the green line. Current conditions are about 14 protons per cubic centimeter. Solar wind speed 440 kilometers per second. And keep in mind, folks, that is measured outside Earth's magnetosphere at Lagrange 1. Let's take a look at the GOES magnetometers, which are measured inside the Earth's magnetosphere, somewhere in the outer portion of the outer Van Allen belt. There are the GOES 16 and GOES 18, and they're geosynchronous near equatorial orbits. And things actually smoothed out. Yeah, so that was a weak coronal hole high-speed stream. We are expecting 2 CME impacts and another stronger coronal hole high-speed stream in the next 2 days. Next, looking at the heliospheric current sheet. Earth is right in the middle of a North Pole-oriented current sheet. Welcome to the North magnetic pole of the solar system. You're right in the middle of it. Here's our line of sight field plot. This depicts the solar B field in blue. The B field being the field that goes through the magnet. When we showed you the ground magnetic perturbations on Earth, those were changes in Earth's B field. These blue lines represent the sun's potential field surface source lines. And then the polar fields are green for north and red for south, which brings us to coronal holes. So here's our coronal hole line of sight plot, and we've got all North Pole oriented coronal holes at the moment. And here we've put up 211 plus 335 angstroms. So we may have some co-interacting regions here. Now keep in mind that when CMEs arrive at the same time as coronal holes, they can amplify each other, they can cancel each other out, or they can both arrive and show obvious signals. So we may see one or more of those signals masked by one of the other phenomenon. Keep in mind, as plasma travels through space, it is primarily positively charged particles, which do have a tendency to repel each other. However, they also tend to align and polarize, which is what causes them to travel through space in filaments largely. So anyway, that's the coronal hole situation, and let's move to sunspots. So again, no new sunspots here. All the groups have names. It looks like 3299 as forecast yesterday. We do have a setting group up here in the northwest. That does increase the likelihood of solar flares a little bit, up there from 3289 and 3292. And here are some great views. 1600 plus 1700 angstroms. Showing sunspots. And thanks for leaving a comment, Mr. Katowski. Katowski? So there's a great close-up, and we can even get a little bit closer than this, getting all the sunspots onto one frame. So there's the SDO continuum. Again, quite stable sunspots here for the past 24 hours, the amount of time depicted in these videos. And John is talking about making me a knight. Okay, that's a great idea. However, I'm mainly interested in getting paid. So visit our links and support the channel. Become a member of the Smash team. Perhaps shop on our Amazon shop. Save some dough on your spices. Or perhaps check out some of my supplements. Or perhaps pick up some merch and go advertise to your friends and foes with our Redbubble products. Don't pole vault the caldera, folks. Our finest days lie ahead. Check out that imagery. That is splentacular. Some quite stable sunspots here. Moving right in the Earth-facing zone. So next we're going to move to energetic particles and solar flares. No spikes in the proton flux here. Proton flux has remained flatlined for an extended period. No solar energetic particle events lately. Goes X-ray flux featuring only a small flare in the past few hours. That happened while we did show prep. And all the flares in the past 24 hours have only been in a C-class intensification range. The 131 angstroms plus 94 angstroms wavelengths should highlight the active flaring regions well. They both happened over here in the eastern limb. Here's a closer view of that. And let's take a moment to take a look up. And of course, we encourage you to look up here at the Smash News Network, least busted name in news. What we're looking at here is a basic star chart, as we're always interested in what's going on overhead. Just head to skyandtelescope.org, put in your location, and click the Now button. And you can get a star chart just like ours for your own location. Once again, we've got Venus chasing the sun across the sky. So if you've got a good view after sunset, go check out the third brightest object in the sky, the planet Venus. As the sun chases Jupiter and Mercury, also Saturn across the ecliptic, those planets can be visible before dawn. Next, your solar system forecast. Here is where things are today. We'll advance this 1 week. Here's where things will be on the 14th. We will have a crescent waning moon. And let's take a look at filaments next. Here at the Smash News Network, Least Busted Name in News, we appreciate your patience. And we also appreciate all of you who have helped support the channel. Now, you may see that there is a paid affiliate/sponsor for this video, and that affiliate/sponsor is Hemp Lucid. So check out the products. If you are shopping on hemplucid.com, make sure you enter the promo code SMASHOMASH to save some dough on checkout. Enter the promo code SMASHOMASH. That's SMASHOMASH. Save some dough on checkout. Or perhaps shop via our link, which is conveniently located below this video, as well as on the homepage at smashomash.com. More on that later in the video. And don't be a moron. Don't be a moron and accept any imposters for your space weather. So here are yesterday's coronagraphs from George Mason University. That's 106 frames from yesterday. And as far as I can tell, I don't believe any of those coronal mass ejections depicted are earthly directed. We've got some on the far side, some that are kind of off to the southwest and the northwest and so on. Here are today's coronagraphs from George Mason. Oh my gosh. There you go. 41 more frames from today. By the way, if you haven't noticed, I have epic patience. Otherwise, I would not be able to put out these videos, and I would have probably hit my computer and possibly myself in the face with a sledgehammer. All right, so here are some coronagraphs. Got the Soho Lasco C2 and C3 here. Is everything in slow motion today? Is that what's going on? Maybe I'm in fast motion and the whole universe is in slow motion. Let us know what you think in the comments. I'm about to overturn this desk and throw at least one computer, not the new one, out the window. That might be unfortunate. Let's don't do that. So those are some coronagraphs. We'll also show stereo A and the Soho Lasco C3 together. If the next tab simply... Oh my gosh. All right. What the is the son of a ching problem? So there's that spectacular CME that happened yesterday morning. I don't know if it's going to play or not, folks, at this point. And I'm running out of patience to give a flying about it. Because I'm getting extremely pissed off! Fuck. Anyway, there's a bunch of CMEs. You're welcome. Jeez. No, you take your time. You take your time. We'll wait. I've got all day. How about some 24-hour videos? Those might actually fucking load. Sweet. So lots of CMEs there. I don't think they're earthly directed. I don't think there is a single earthly directed component in any of those. The best candidate is the one that goes off to the northwest and southeast. And I don't think that was even on the Earth side of the solar disk. I think that was on the far side. Let us know in the comments what you think. If you disagree, agree, or if you've got something belligerent or ridiculous to say, we invite your comments. We do read them all. And keep in mind, we are free speech purists, so we will not censor you. There are a lot of YouTube channels that will mute, ban, and block people from being able to comment on their videos. You'll see your comment on YouTube, but nobody else will. It's called censorship. And there are a lot of hack frauds that call themselves, quote, scientists, end quote, that have no idea how science works. Otherwise, they would be able to handle criticism, and they wouldn't need to lock themselves in an isolated location where nobody can refute them on their utter crap disguised as science. Here's the past 24 hours in SGO 193 angstroms. And let's get back to where we were. Filaments. Filaments are the next situation. This is the ground-based Hydrogen Alpha telescope at El Teide, Spain. And the filament count is much lower than it was. There are still some filaments mainly in the southern hemisphere. There's been a lot of house cleaning and a lot of CMEs in the past few days. The filament count has dropped precipitously. And here are the past couple of hours. That is the GOES 16 SUVI. Ionized helium, 304 angstroms. There is certainly still some activity going on down here. I can see stuff vibrating around. And with a lot of sunspots facing the Earth, remember, folks, you don't need to see a large solar flare to see an Earth-directed coronal mass ejection. So we'll be streaming this once again throughout the day today. And let's move to our bonus feature segment, starting with satellite charging hazards. At the moment, just some minor surface charging hazards here in the Eastern Pacific. That shouldn't cause any major communications breakdowns. Those low-energy electrons there building up on the outsides of satellites. The GOES electron flux has dipped as forecast. So there is the past 3 days of the GOES electron flux measured by the GOES 16 and GOES 18 from their geosynchronous orbits. There's the forecast model. You can see it's right about where we forecasted yesterday. See yesterday's daily space weather video for details if you don't believe me. Or if you want to watch any days, we're pushing 6 years on putting out daily space weather videos. And we're expecting this to remain kind of low. NOAA tends to agree with that. Although these two green boxes here are probably slightly too high for reality. Here's a 1-year graph to put it in context. Coming off those lengthy highs, following a lengthy period of low electron flux. That's the greater than 2 mega electron volt electron fluence. That is measured at the F layer of the ionosphere. So feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation, thermospheric temperatures, and thermospheric molecular concentrations. Here is the vibrational frequency of the ionosphere in megahertz. That is millions of vibrations per second. Ionosphere is not all that perturbed. Yesterday's brief geomagnetic storm was just that. It was a minor pulse from a glancing blow from the south heliographic North Pole-oriented coronal hole system. Ionosphere is a little bit anomalous. And let's show the anomalygram to highlight those anomalies. This is anomaly in megahertz from a 30-day median. Red for low-frequency anomaly, blue for high-frequency anomaly. And it looks nothing like it did right after the most recent KP8 geomagnetic storm. The whole map was red because the whole ionosphere was puffed up. That causes more material to be in the ionosphere, which causes it to vibrate more slowly. It's telling you about density, basically, folks. It's telling you about density. The blue areas are going to be hotter, and the red areas are going to be cooler with more material in them. And we'll also show the total electron content. So here's the latest image. That's 1115 universal time ionogram and 1115 universal time anomalygram. Total electron content depicts free electrons out to the inner Van Allen belt. Now, the outer portion of the inner portion of the outer Van Allen belt. That's where your GPS satellite's located. Your NASA GOES satellites are located in the outer portion of the outer Van Allen belt at about 23,000 miles of altitude. Here is the total electron content. This will show you the most likely places to see GPS errors. Turn on your Wi-Fi location accuracy. If you're expecting GPS errors, that could help things. This is literally depicting the free electrons in the thermosphere, ionosphere, plasmasphere electrodynamics model. Here is the North American total electron content anomaly map. Not sure why those stations are turning on and off. Those red dots you see there, those are the ground stations that are measuring signal refraction. That's how the electrons are counted. So there may be a bunch of missing data there. I'm not sure what's going on with that. But it's time to move on to close out the space weather section of this video and cover the latest high-resolution magnetogram and intensitygram. I don't think there are any new sunspots at the moment. And I stand corrected. There is one down here. So there is at least one new named sunspot group. It looks like an alpha class sunspot group. Let's try that again. The heck? And indeed, I only see one South Pole-oriented umbra there. That is, I'm going to say that's an alpha-class sunspot. One more named group, though. That was kind of unexpected. And let's move on to our meteorology segment. So here at the Smash News Network, Least Busted Name in News, we like to add value-added services. And we'd be happy to make these videos all separate. However, it hurts our number of views on YouTube. I know, that sounds crazy, right? It seems like it would be optimal to put out like 15 2-minute videos instead of one 40-minute video, but that's not how it works at all. YouTube, the algorithm, is completely broken, and it is not looking out for your best interests by any stretch of the imagination. So what we're doing here is we're looking at surface winds and significant wave height. The animation is the surface wind scenario. The shaded portion is the wave height, and the world's largest waves are probably not being enjoyed by anybody. They're deep in the Southern Ocean, but they are over 30 foot. Those are the world's largest waves. I'm a wave chaser. If you want to chase waves yourself, check out nullschool.net. That is the significant wave height and the surface wind scenario. So let's switch back to the pure surface wind scenario. And sometimes you have to press refresh, by the way, folks. Sometimes you have to press refresh. So there's the surface wind scenario for the eastern world. Okay, maybe not. So there is a bunch of nothing right there. Although the Smash News Network least busted name in news is far from nothing. It is something. And yeah, each and every tab is currently broken. So I don't know. Maybe I'll just snap. Oh my gosh. So yeah, nullschool.net is telling me it's downloading. Maybe that's not our fault. It's definitely not our fault, folks. So I'll press refresh one more time. We're going to have to refrain from showing you the surface winds and jet streams around the world. You can view it yourself at nullschool.net. Whatever. And today we're going to show the long wave infrared radiation map. Yeah, the dirty infrared radiation. So we normally show clouds and fog at this point in time. And dude, I'm telling you, our internet connection is blazingly fast. Blazingly fast! Nope. It's just not loading jack shit. It's not loading jack shit, folks. So, yeah, I mean, at least we got the space weather video portion done. This other data, there we go. Oh my God, the data is actually loading. That's fantastic. Thank goodness for small favors. Wow. Son of a Anyway, I figured I'd show you something differently today. That was fun. This is the long wave radiation map. So this shows water vapor, basically. It's showing infrared radiation, so it'll show water vapor, clouds, and fog. And the color scheme there is it's showing you the temperature of cloud tops. I mean, here's the key. Where's the key? I guess the key is on the main page, not the animated page. So there's the key. It shows intense cloud tops and so on. The long wave radiation map. I'm perhaps as unimpressed as you are at this point. Here's our weather.gov map. These are the weather warnings for the U.S. And I swear every input that I do here takes like 5 minutes for anything to happen. It's a perfect day to retire this computer. And by the way, we are retiring this computer today. The new PC is sitting right here on my desk, not being used yet because it's not set up yet for this. Anyway, there are your weather warnings. If your location is lit, head to weather.gov, a barely functional website that might work on your barely functional Microsoft computer. We've got some weather warnings here. Are those tornado warnings? Flash flood warnings there in central Illinois. Here are some weather forecasts that we brought up in convenient GIF animation form so that not a lot has to load. Yeah, it's a local file at this point. That's your temperature anomaly forecast for the next 72 hours based on a GFS model. There's going to be a lot of snow melt continuing as time goes on, as there's still a ton of snow that is yet to melt. So if you're downstream from that, be prepared, especially if you're seeing hot temperatures showing up. That's your 72-hour GFS temperature anomaly forecast in degrees Celsius, and here is your pressure and precipitation forecast based on the same model, the GFS 72-hour pressure and precipitation forecast. Some severe weather here coming to Kansas in about 3 days. The eastern side of the state, as you can see there, that'll be the most severe weather. Also some heavy storms around Galveston are forecasted. You can see there also in about 3 days' time. Also some snow will continue to fall in certain places. And let's move on and get this thing closed out so it can get onto your screen as soon as possible. Here is your NASA Goes Lightning Mapper, which is frozen. because reasons. So I'm just going to skip that and move on to the real-time lightning map, which is, you're welcome. Here's a great white screen for you. I'm sure that's not annoying as hell. It's sure pissing me off. Keep in mind, folks, I am the space weather rager. So here are the current lightning strikes. We've got lightning strikes around Louisville, as well as in Michigan. We'll zoom out. Hopefully, if any of my fucking inputs actually do anything. There is your lightningmaps.org real-time lightning map. And when I say real-time, I mean it takes 2 hours for any inputs to do anything. Oh my gosh. It's my blood pressure right now is like 200 over 100. Okay, you could simply go to the next tab. That would be great. Wouldn't that be great, folks? Yeah, I would be freaking delighted if that happened. But nope. That's too much to ask. So you know what? Here's too much to ask. How about if we get to see the Aurora over Lehigh Valley, Pennsylvania tonight? That would be great. That would be just freaking wonderful. Now that I've gotten that out of my system. Yeah, I'm not waiting for this browser to reopen. You want more weather stuff? I don't know. You've got the internet. Go look it up yourself. In the meantime, may that solar wind be at your back. We hope you get to see the Aurora. If you do see some, share it with us on Instagram or better yet on Twitter. We'll see you soon at the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-A-Mash, signing off and getting the sledgehammer. Bye!